All right, instructional video number 2. We're talking about spheres and cones and finding their volume. So something you will find as you are finding like the volume of a sphere is it's going to seem way bigger than it should. And a good kind of rule of thumb to see, am I on the right track? Does this seem right? Is imagine, and let's just pretend like this is going to be an amazing drawing. Imagine that this sphere fit inside a cylinder perfectly. Okay, so it was like let's call this a basketball, and it's in this perfect trash can that fits it exactly. This trash can has the exact same diameter, and if that's the diameter, right, if 9 feet is the radius, not the diameter, then if the radius is 9, the diameter would be 18 feet, and the height here would also be 18 feet, right? So a good rule of thumb is that the volume of a sphere should be about 2/3 that of a cylinder that sphere would fit in perfectly. So we're going to go ahead and we're going to find the volume just of the sphere, but then we're going to test it out and see, is it 2/3 of the cylinder that it would fit in exactly, okay? So let's first just talk about how to find the volume of a sphere. I'm just going to give you yet another formula. So the volume of a sphere is equal to 4/3 pi r cubed. And go ahead and toss a multiplication symbol in between there so you don't get confused. You're 4/3 of pi, so it's going to be a little more than pi, right? 4/3 is an improper fraction. It's more than 1, times the radius cubed. For the record, even if we were in class right now, I would not expect you to memorize all of these equations, these formulas rather. I would give them to you on a cheat sheet, okay? So don't stress. Moving forward in your next geometry class, this will all be reviewed again. So it's all good. It's more so that you can look at the formula and follow it. That's kind of our goal right now, okay? So 4/3 times pi times the radius cubed. So let's go ahead and toss a few things in here. I'm going to pull up my calculator. So our radius is 9 feet. 9 cubed is the same as saying 9 times 9 times 9. When we do that, we get 729. So we need to do 4/3 times pi times 729. Let's go ahead and do 4/3. 4 divided by 3 is 1.333333 times 3.14 is 4.19. It's actually 1.86667, but we'll round up. 4.19 times 729 times 729. And when we do that, our volume of this sphere is 3,052.1 cubic feet. That seems enormous, doesn't it? To me, that seems really big. However, if this is a 9-foot sphere, picture an 18-foot across sphere. Under what circumstances are we going to be looking at an 18-foot across sphere? I literally can't. I have no idea. Giant globe, gigantic rubber band ball. I have no idea. But let's go ahead and test this idea of, okay, well, if we had an 18-foot tall cylinder, right? If this ball fit into that perfectly, it should be 2/3 the volume of the cylinder. So going back to finding our volume of a cylinder, right? It's the area of the base times the height. So our area of, I didn't mean to erase that. Area of the base, right? Our area of a circle is, pi times the radius squared. So our radius squared, our radius is still 9, right? So 9 times 9 is 81 times 3.14. So the area of that, we're talking about the cylinder here, the area of the top would be 254.34. And then we just multiply that by the height. So the height of this cylinder is 18 feet, right? It is going to be that radius twice. So 254.34 times 18 equals 4,578 and 12 hundredths. Now, if we find 2/3 of that, if we multiply that by 0.666666, we get 3,052. Check it out. So it's kind of a cool rule of thumb to just check your work. It should be the volume of a sphere should be 2/3 the volume of a cylinder that sphere fits in perfectly. But if that feels like too much to think about, that's also okay. Or maybe I shouldn't have erased that. I'll leave that on the notes. 2/3 of a cylinder. I will neaten this up a little bit. Zoop. This right here is what you really got to be able to follow. The volume of a cylinder, or not of a cylinder, I'm sorry, volume of a sphere is 4/3 times pi times the radius cubed. Okay. Now, volume of a cone, our formula for that one, and again, I do not expect you guys to memorize these. I can picture some of your faces in class right now if we were doing this, and you would be all panicky and like, Ms. Ritter, it's too many formulas. I'm not expecting you to memorize these. I'm just expecting you to be able to look at them and plug in whatever numbers you got to plug in, okay? So our volume of a cone is going to be pi times the radius squared times the height divided by 3. So in this case, I'll make you a little key. H is equal to the height. Okay, so over here, when we look at this cone, our height is 28 and our radius is 15. Okay, so let's go ahead and plug some things in. Our volume is equal to pi times our radius squared. Our radius is 15, so 15 times 15 is 225. And we need to multiply that by the height divided by 3. So let's take our height, 28, and we'll do 28 divided by 3. It's 9.3. So now we've got pi times 225 times 9.3 repeated. Okay? So let's go ahead and now solve for the rest of them. Pi, we've got 3.14 times 225 times 9.333333. And we get 6,594 is the volume of this cone. When do we see cones in our life? They hold ice cream for us. They are used on the roads. What else do we see cones? Party hats. So this cone has a volume of 6,594 cubic centimeters. Awesome. So today we have reviewed finding surface area and volume of cylinders, and then also how to find the volume of spheres and cones. I will leave a copy of these notes on, maybe I'll even clean them up for you a little bit, along with the materials of these video clips. That way you can reference them and you'll have, I'll make a list here of all of the formulas for you. So as you are working through this week's check-in, you've got all the material you need. I'm super proud of you guys.